Hi, today I'll be going over how to solve a question from Energizing Physics Lesson 4.7. So this question says that Ben bungee drops with a 40-meter cord from a height of 100 meters, as shown in the diagram. The cord applies an average force of 1,500 newtons when stretched. So part A of the question asks how long it'll take Ben to fall to a height of 60 meters. Note that Ben starts from an initial height of 100 meters. And that the cord length is 40 meters. So that means that when he reaches a height of 60 meters, which is what the question is asking for, that is equal to falling the length of the cord. And since Ben is only falling the length of the cord, it means that the cord has not stretched yet, which means that there is no EPE or force exerted by the cord yet. So that means that until height of 60 meters, the only force that Ben experiences is the force of gravity. So because the only force is gravity, we know that his acceleration throughout this period is g, which is just negative 10 meters per second squared. And we also know the equation that delta x is equal to 1/2 at squared. And since his velocity is 0 initially, we can just have this. So yeah. So delta x is 40. Because to get to a height of 60, he falls 40 meters, which is the delta x, is equal to 1/2 10 t squared. So t squared is equal to 40 over 5, which is equal to 8. T is equal to square root of 8, which is equal to about 2.8 seconds. And now we're moving on to part B, which is how long it will take Ben to reach the bottom of his drop. So since we know the acceleration from 100 to 40 to 60 meters is A is equal to g, we can calculate what his velocity will be at this point. So 2ax is equal to delta v squared, which is a physics equation. And we know 2, 10, 40 is equal to delta v squared. So 800 is equal to delta v squared. And that means delta v is going to equal to the square root of 800, which is equal to 28.3 meters per second. So that's his velocity at the beginning of this period between. So we want to figure out how long it'll take him to reach the bottom of his drop, and we know that at the bottom of his drop, his velocity will be 0. So v final is equal to 0 meters per second. And we also know that his net force, but after the cord starts stretching, is going to be F net is equal to 1/500 minus 600, which is equal to 900 newtons. And since F equals ma, we know that his A net is equal to 900 over 60. And we know his mass is 60 because his force of gravity is 600. So 900 over 60 is equal to 15 meters per second squared. So we know that AT is equal to delta V, and since he started with a velocity of 28.3 at this period, we know that T is going to equal to 28.3 over 15, which is equal to 1.89 seconds. So that's how long it takes for him to reach his final velocity, his final point, where his velocity is 0. So next, part C asks, what will his height be above the ground when he reaches the bottom of the drop? So we can do this in two ways. I'll show you the more complicated way first. So delta x is equal to 1/2 AT squared plus V0t. So, just to return to part B, t is equal to 1.89, meaning that's the time it takes between the stretches 60 to final. So if we want to get the final time, it's going to be 1.89 plus 2.8, because that's what we had before. So the final time the total time would actually be 4.69 seconds. Yeah, just sorry for the clarification. And then part C asks for delta x is equal to 1/2 AT squared plus V0t, and this is delta x in the time between 60 meters and final, h final, is equal to 1/2. We know that the acceleration during this period is 15, and then it's t is 1.89, because we're using the time between here, not from the top, minus, because his velocity is facing downward, 28.3, and it's also 1.89. So delta x is equal to 0.5 times 15 times 1.89 times 1.89 minus 28.3 times 1.89 is equal to negative 26.7 meters. So this is 26.7 meters lower than his height of 60. So his h final is equal to 60 minus 26.7, which is h final equals 33.3 meters. So I also said I'd show you an alternate method of doing this, which is simpler because it only uses a few variables. So remember, 2ax equals delta v squared, and we know that delta v is 28.3. So x is equal to 28.3 squared over 2 times 15. So which is equal to also to 26.7. So that's another way to solve and still get the same h final, because 60 minus 26.7 is equal to 33.3. So that is this question. Thanks for listening.